Good morning, learners. Today we are differentiating using rules. Well, rules are put in place for people to observe them. And therefore, under this topic, we have got rules of differentiating. Let me just first of all give you the symbols that we shall meet as we study this part of our topic. Symbols. You will meet the f dash of x, which we have defined as the gradient. For those of us who are following what we are doing, and this gradient was also equal to limit as h goes to 0 of f of x plus h minus f of x all over h. So we are going to meet this, which we have already met anyway. What else are we going to see? We shall meet d of dx. This is saying we are differentiating with respect to x. We are differentiating with respect to x. Given our f of x, then we should be able to differentiate it with respect to a variable. In this case, it's x. And this can also be written like that. This means we are differentiating with respect to x. So it's exactly the same as we have said above. In general, if we have a function f of x is equal to a x to the power n, then f dash of x will be given by, this is the procedure, it's a rule. You don't have to ask me why. We take this n, we write it to multiply ax. So there will be anx. Then the n comes back, but we subtract 1. All we are saying, f of dash of x is actually equal to an x to the power n minus 1. It's a rule. Take the power down, multiply the coefficient of x, and then the x comes back with a power 1 less than n, which means it's n minus 1. Important for us to bear in mind is that we do not differentiate anything like this one. We first of all write it in the language of exponents, which we all know it has a power of half. So now we can differentiate. Very, very important for you to notice. If we have root of x over x squared, we first of all apply our exponent rules. It will be x to the power half over x squared. This again will be x. We are dividing the same base, different powers, power of denominator minus power of numerator, half minus 2. And this will give us x to the power minus 3 over 2. So we can now differentiate this. And the rule does not change. When you are differentiating any term which has got x as a variable, the power of x comes down. Multiply the coefficient of x, and the power of x is reduced by 1. And you can, in this case, you see it to be minus 3 over 2 minus 1 when we differentiate. And if we have x squared over x squared, for this one, you will notice that according to exponents, this is x to the power 2 minus 2, which is 0. So what is a number to the power 0, 1. In other words, we are differentiating a constant. And let me make it clear here, when you differentiate a constant, you always get a 0. In other words, if we differentiate 1, our answer is 0. We don't think. We shall meet expressions like 4 minus x over x. Now this should be written as 4 over x minus x over x. See, if you simplify this, you get that. Now this will become 4 over x minus 1. But we do not differentiate a variable which is in the denominator. So we shall take it up. It will be 4x to the power minus 1 minus 1. Very, very important for you to understand what is going on there. And last, for these examples, we have x to the power 1/3 multiplied by x to the power 3 over 4. As usual, it's x because the base is the same. We add the exponents. And as we know, this is x. Common denominator is 12. 3 into there, 4. 4 times 1, that's 4. 4 into that, 3 times 3, that's 9. So this will give us x to the power 13 over 12. Then we are now able to differentiate. As usual, this will come down, but we answer questions. We don't just differentiate if the question is not asking us to differentiate. In this case, I was showing you how to manipulate given expressions for them to be able to be differentiated. Please note that the derivative of a constant is 0. So the derivative of a constant is 0. If we are differentiating a constant k with respect to x, then the answer is 0. If we are differentiating a minus 7 with respect to x, then the answer is 0. Whenever you differentiate a constant, the solution is 0. Very, very important. Let us now look at some examples to reinforce our understanding. Examples. Number 1, it reads, find the derivative a f of x equal to 2x minus 3 into 4x plus a 1. Now, the first thing we need to do here is to expand 2x times 4x. That's 8x squared. 2x times 1, that's plus 2x. Minus 3 times 4x, minus 12x. Minus 3 times 1, minus 3. There are still like terms here. Our like terms are 2x minus 12x, which gives us minus 10x, then minus a 3. The question says find the derivative. So our derivative f dash of x is equal to, now we are differentiating. We said the power of x comes to multiply the coefficient of x. So we shall have 16. Then our x to the power 2 minus 1, that's 1. I don't write a power of 1 because any number written down without a power has a power of 1. What is the power of this x? 1. 1 times minus 10, minus 10. X to the power 1 minus 1, that's x to the power 0, which becomes 1. So it's minus 10. What is the derivative of a constant? It's 0. We don't write that. So we have managed to find the derivative of f of x. Next, it's part B. It's saying dx, no, that's number C. It's y is equal to 3 over x. We are again required to find the derivative. So first of all, before we do any derivation, we remove the x from the denominator. So it's 3 to the and x to the power minus 1. Then now we can find our dy dx. We are differentiating y with respect to x. This will give us minus 1 times 3 minus 3. X to the power minus 1 minus 1. That's minus 2. We then becomes minus 3 over x squared. We are applying exponential rules there. Part C, we are moving on. We are not waiting for anyone. Part C is saying dx of root of x to the power 5. This is equal to, the dx only disappears when we start to differentiate. So I'm not differentiating at all now. What am I doing? I'm writing this in a language that I can apply the rule. So it will be dx comes back. What is this? This is x to the power 5 or this to the power half, because there is square root. Then this is dx root of x. We multiply the exponents, which is 5 over 2. Then now at this point I can differentiate. The dx does not come anymore. It will be this comes down. It is multiplying the coefficient of x, which is 1. So it's 5 over 2. Then x to the power 5 over 2 minus 1. We remain with 3 over 2. You can leave your answer like that. Part D, the question says dx of x squared minus 5x minus 6 all over x minus 6. Again, we do all that we can to try and simplify what is inside the bracket. So our dx, I'm not differentiating yet. I'm just writing it in a language where I'm able to differentiate. I'm looking for factors of the numerator. It will be x minus 6 into x plus a 1. I'm not teaching you how to factorize. Everyone should be able to factorize. All over x minus 6. You see, this is exactly that. So what are we differentiating? We are actually differentiating in brackets x plus 1. So we are differentiating x plus 1 because we simplified. This becomes what? We are now differentiating. What is the derivative of x? It's 1. What is the derivative of 1? It's a 0, because we said the derivative of a constant is always 0. Part E. Part E is saying s is equal to minus 5t squared plus 3t. You cannot derive this with respect to x. If you do derive with respect to x, the answer is 0. So here we are finding the derivatives. So the derivative of this one is ds dt. We are deriving with respect to t. It is in the proper form of differentiating. So we go on. The 2 goes down to multiply the minus 5. You get minus 10. 2 to the power 2 minus 1. That's a 1. Plus the 1 comes down to multiply the 3. We get 3. That's t to the power 1 minus 1, which is 2 to the power 0, which is also 1. So we have found the derivative of this function. Then we are moving on to question 2. Question 2 is saying, determine using the rules of differentiation. A, we are required to get the f dash, given that f of x is equal to 7x squared minus 5x plus 4h. So, for us to find f dash of x, we are using the rules. So the 2 comes down, I have 14x to the power 2 minus 1, that's 1. Then this gives us a minus 5. There is an h and a 4. This is a constant because we are deriving with respect to x. So it means that is our answer. Then part B says, dy dx if y is given by 3x squared minus 9x minus 2. So our dy dx, which is the derivative, please don't confuse yourself. This is the derivative. This is the derivative. It's only notation. And the dx, capital dx, is also the derivative. This is equal to, it's already in the correct form for us to differentiate. The 2 comes down, I have 6x. The 1 comes down, I have minus 9, because this will be x to the power 0. This is a constant, we get a 0. This is the derivative. Part C. Part C is saying y is equal to bracket x minus 3 into 2x minus 1. We want to find dy dx, but then first of all let us write this in a language that we understand. This times this we get 2x squared. This times this, that's minus x. This times this minus 6x. So together we get minus 7x. This times this we get plus a 3. At this point we are able to differentiate. Dy dx is equal to, it comes there, it's 4x. There is a 1, it multiplies the minus 7, we get minus 7, then 0. We have